Lotus Academy of Diet and Fitness.
Comprehensive food science. Chapter 3. Food processing. Food processing involves the conversion of raw ingredients into processed or prepared food products using physical, chemical, and biological techniques. The primary goals are to enhance safety, quality, shelf life, and convenience while creating appealing products. Key methods include heat treatment, widely applied to eliminate harmful microorganisms, enzymes, and spoilage organisms. Methods such as pasteurization, boiling, blanching, and sterilization enhance food safety and shelf life. Heat treatment can also improve digestibility and palatability. Freezing. This preservation method lowers food temperature, slowing microbial growth and enzymatic activity. Commonly used for fruits, vegetables, meats, seafood, and ready-to-eat meals, freezing maintains nutritional quality, texture, and flavor. Drying. Removing moisture inhibits microbial growth and enzymatic reactions. Methods like sun drying, hot air drying, freeze drying, and spray drying preserve fruits, vegetables, herbs, grains, and meat. Dried foods are lightweight, have a long shelf life, and can be rehydrated. Fermentation. Microorganisms convert sugars and carbohydrates into acids, alcohols, or gases, enhancing flavor, texture, nutritional value, and shelf life. Examples include yogurt, cheese, sauerkraut, kimchi, and sourdough bread. Canning. Sealing food in airtight containers and subjecting it to heat destroys microorganisms, ensuring a sterile environment and a long shelf life for canned fruits, vegetables, soups, sauces, and meat products. Packaging. Crucial for protecting against contamination, moisture, light, and oxygen. Packaging maintains food quality, freshness, and safety during storage, transportation, and distribution. Materials include glass, metal cans, plastics, and flexible films. Extraction and refining. Used to obtain oils, sugars, and other valuable components from raw materials, extraction methods involve mechanical pressing or chemical processes. Sugar extraction refines raw sugar from sugarcane or sugar beets. Principles of food processing. Food processing involves a series of techniques and methods applied to raw or semi-processed food materials to transform them into edible, safe, and marketable products. Here are some key principles of food processing. Preservation. Preventing spoilage and microbial growth through methods like canning, freezing, drying, pasteurization, and preservative use. Heating and cooling. Proper heat application during processing and cooling prevent harmful bacterial growth. Removal of water, dehydration, freeze drying, and evaporation inhibit microbial growth by removing water. Hygiene and sanitation. Maintaining high standards throughout the processing chain to prevent contamination. Quality control. Regular checks and adherence to safety standards ensure consistent, high-quality products. Use of additives. Regulated use of additives to enhance taste, appearance, and texture. Minimization of nutrient loss. Techniques to preserve nutritional value during processing. Packaging. Proper packaging safeguards against physical damage, contamination, and deterioration. Process optimization. Optimizing methods for desired product characteristics while minimizing energy consumption, waste, and processing time. Sustainability. Considering environmental impact, waste reduction, and resource efficiency. Compliance with regulations. Adhering to local and international standards for consumer safety and fair trade practices. Heat treatment in food processing. Heat treatment is a pivotal method in food processing, contributing to the safety, shelf life, and quality of food products. The controlled application of heat for specific durations employs various techniques, each serving distinct purposes. Common methods include heating and cooling. Proper heat application destroys harmful bacteria and enzymes, ensuring food safety and prolonging shelf life. Cooling techniques prevent post-processing microbial growth. Removal of water, dehydration, freeze drying, and evaporation inhibit microbial growth by removing water from food items, reducing spoilage risk. Hygiene and sanitation. Maintaining high hygiene standards prevents contamination, crucial for preventing foodborne illnesses. Quality control. Regular quality checks and adherence to safety standards ensure consistent, safe, and high-quality products. Use of additives. Regulated use of additives enhances taste, appearance, and texture, but safety considerations are crucial. Pasteurization. A mild heat treatment destroying pathogens without significantly altering taste or nutrition. Types include high-temperature short-time, HTST, and low-temperature long-time, LTLT, pasteurization. Sterilization. Intense heat treatment eliminating all viable microorganisms, commonly applied in canning. Blanching. A brief heat treatment preserving color, flavor, and texture in fruits and vegetables before freezing. Cooking. Applied to a variety of food items. It not only ensures safety, but also enhances flavor, texture, and digestibility. Baking and roasting. Dry heat application in an oven, resulting in the Maillard reaction, enhancing flavor and browning. Frying. Submerging food in hot oil for quick cooking and a crispy texture, but excessive frying can increase fat absorption. Drying. Removes moisture from food items, commonly applied to fruits, vegetables, herbs, and meat. UHT, ultra-high temperature treatment, high temperature, short-time sterilization for liquid food products, extending shelf life without refrigeration. Benefits of heat treatment in food processing. Food safety. Destroys or reduces harmful microorganisms, minimizing the risk of foodborne illnesses. Extended shelf life. Inhibits spoilage-causing microorganisms, enzymes, and molds, extending the shelf life of processed foods. Minimization of nutrient loss. Techniques like minimal processing help preserve the nutritional value of food. Packaging. Essential for protecting processed foods from physical damage, contamination, and deterioration. Process optimization. Methods should achieve desired characteristics while minimizing energy consumption, waste generation, and processing time. Sustainability. Modern practices consider environmental impact, waste reduction, and resource efficiency. Compliance with regulations. Adherence to local and international standards ensures consumer safety and fair trade practices. Improved digestibility. Heat processing breaks down complex components, enhancing digestibility. Enhanced flavor and texture. Develops flavors, aromas, and textures, enhancing sensory appeal. Nutritional preservation. While causing some nutrient losses, it also enhances the availability of certain nutrients. Losses during heat treatment. Nutrient losses. Heat-sensitive vitamins may degrade during treatment. Texture changes. Overcooking can result in mushiness or loss of crispness. Flavor changes. Excessive heating can lead to flavor degradation, especially in delicate foods. Destruction of beneficial compounds. Bioactive compounds may be destroyed, reducing potential health benefits. Formation of harmful compounds. High-temperature cooking methods may lead to the formation of harmful compounds associated with health risks. Refrigeration and freezing process in food processing. Refrigeration and freezing are indispensable processes in food processing, playing a pivotal role in preserving the quality, safety, and shelf life of perishable food items. These methods, both focused on temperature control, are vital for inhibiting the growth of spoilage microorganisms and enzymes, as well as maintaining the nutritional content and sensory attributes of various foods. Refrigeration, involving storage at temperatures between 0 degrees Celsius 32 degrees Fahrenheit and 5 degrees Celsius 41 degrees Fahrenheit, induces a state where most bacteria and spoilage microorganisms become inactive or grow very slowly. This significantly extends the shelf life of perishable foods, including fresh fruits, vegetables, dairy products, meat, fish, and ready-to-eat meals. Refrigeration also mitigates chemical reactions responsible for food deterioration, such as enzymatic browning and lipid oxidation. Proper maintenance of storage temperatures and regular cleaning of refrigerators are essential to prevent cross-contamination and foodborne illnesses. On the other hand, freezing, characterized by reducing temperatures below 0 degrees Celsius 32 degrees Fahrenheit to form ice, effectively halts the growth of microorganisms and enzymatic activity. This process dramatically extends the shelf life of foods, ranging from fruits and vegetables to meat, poultry, seafood, and prepared meals. Rapid freezing is preferred to minimize cell damage and preserve texture. Adequate packaging is crucial to prevent freezer burn and uphold product quality, requiring moisture-resistant and airtight materials. Both refrigeration and freezing processes offer a multitude of benefits. Refrigeration aids in preserving freshness, extending shelf life, causing minimal nutrient loss, providing convenient storage, and retaining sensory attributes. It is also cost-effective for short-term storage. Freezing, on the other hand, prolongs shelf life significantly, retains nutritional content, allows for the availability of seasonal foods throughout the year, and offers convenient storage and preparation options. Drying and dehydration process in food processing. Drying and dehydration are vital food processing techniques employed to eliminate moisture from food items, thereby extending shelf life and averting spoilage. While both methods utilize heat to facilitate water evaporation, distinctions exist between the processes. Drying process in food processing. Drying, an umbrella term, encompasses diverse methods like natural drying, sun drying, and mechanical drying. Natural drying involves exposing food to air and sunlight for moisture evaporation, commonly used for fruits, vegetables, and herbs in low humidity regions. Sun drying. Control conditions where food is placed on racks or trays under the sun, prevalent in tropical areas for products like raisins. Mechanical drying employs specialized equipment such as hot air dryers, vacuum dryers, or freeze dryers for rapid and efficient moisture removal, primarily in large-scale commercial processing. Dehydration process in food processing. Dehydration, a specific form of drying, employs controlled heat and airflow at low temperatures, 40 degrees Celsius to 17 degrees Celsius or 104 degrees Fahrenheit to 158 degrees Fahrenheit, to preserve nutritional value, color, and flavor. Tray drying. Food spread on trays with warm air circulating to gradually remove moisture. Spray drying atomizes liquid food products into a hot chamber, where water evaporates quickly, leaving behind dry particles. Freeze drying freezes food before subjecting it to a vacuum, causing frozen water to sublimate directly from ice to vapor, preserving the food's structure and characteristics. Benefits of drying and dehydration in food processing. Extended shelf life. Inhibits microorganism and enzyme growth, leading to longer storage periods without refrigeration. Nutrient retention. Preserves vitamins, minerals, and antioxidants, with minor nutrient losses during drying. Space and weight efficiency. Reduced water content results in lighter and less voluminous dried foods, ideal for storage and transportation. Flavor concentration. Enhances and concentrates natural flavors, producing rich taste profiles. Versatility in usage. Dried foods can be consumed as is, rehydrated, or used in various recipes, offering flexibility in cooking applications. Losses during drying and dehydration process. Nutrient losses. Heat-sensitive nutrients may experience losses, but overall nutritional content is generally well preserved. Texture changes. Removal of moisture can alter the texture, making certain foods leathery, tough, or brittle. Flavor alterations. While flavor concentration is a benefit, some foods may undergo flavor changes during drying. Enzyme activity. Active enzymes in foods during early drying stages may lead to quality changes, mitigated through blanching or pre-treatment. Rehydration time. Rehydrating dried foods may require additional time and effort compared to fresh counterparts, necessitating soaking or prolonged cooking. Fermentation and bioprocess in food processing. Fermentation and bioprocessing are pivotal techniques in food processing, utilizing microorganisms to convert raw or processed food materials into diverse products. These methods, with roots reaching back centuries, continue to hold a vital role in modern food processing. Fermentation in food processing. Fermentation, a metabolic process, involves microorganisms converting sugars into products like alcohol, organic acids, gases, and flavor compounds without oxygen. Yeasts are commonly used for alcoholic fermentation, while lactic acid bacteria drive lactic acid fermentation. Examples of fermented foods span bread, beer, wine, yogurt, cheese, pickles, sauerkraut, kimchi, and soy sauce. Fermentation enhances flavor, texture, and shelf life, while also improving nutritional value by simplifying complex molecules. Bioprocess and food processing. Bioprocessing, a broader term, encompasses techniques utilizing biological agents like microorganisms, enzymes, and cells to produce or modify food products. It spans microbial bioprocessing, enzymatic bioprocessing, and cell culture-based bioprocessing. In the food industry, bioprocessing yields enzymes for bread making, brewing, and dairy processing, as well as bioactive compounds such as vitamins, amino acids, and peptides. Benefits of fermentation and bioprocess in food processing. Preservation and shelf life extension. Fermentation acts as a natural preservative, creating environments inhibiting harmful bacteria growth, extending shelf life. Enhanced digestibility. Fermentation breaks down complex compounds, aiding digestion and improving nutrient bioavailability. Flavor development. Fermentation introduces unique and complex flavors, aromas, and textures, shaping the taste profiles of foods. Nutritional enhancement. Fermentation increases the availability of vitamins, probiotics, and enzymes, enhancing the nutritional value of foods. Preservation of beneficial microorganisms. Fermented foods contain live microorganisms, like probiotics, benefiting gut health. Considerations during fermentation and bioprocess. Food safety. Adherence to hygiene practices and use of clean equipment minimize contamination risks. Controlling fermentation conditions ensures safety. Monitoring and control. Vigilant monitoring of factors like temperature and pH is essential to achieve consistent and desirable results. Sensory changes. While fermentation introduces unique tastes, individual preferences may vary. Time and process considerations. Fermentation is time-consuming, requiring patience for optimal outcomes. Allergen considerations. Allergen labeling and precautions for individuals with food allergies are crucial. Canning process and food processing. Canning is a widely embraced food processing technique employed to safeguard perishable foods by sealing them in airtight containers and subjecting them to heat, eliminating microorganisms and enzymes responsible for spoilage. The process encompasses several steps to guarantee the safety and longevity of canned food products. Beginning with the selection of fresh, high-quality raw materials, including fruits, vegetables, meats, and other items devoid of spoilage, damage, and contamination, the canning process proceeds through crucial stages. Pre-processing. Prior to canning, raw materials undergo various pre-processing steps, encompassing washing, peeling, cutting, blanching, and occasionally, the addition of sugar or salt for flavor and preservation enhancement. Filling. The pre-processed food is meticulously filled into clean, sterilized cans or jars, ensuring airtight seals to prevent contamination. Sealing. Cans or jars are sealed tightly using a seamer machine for metal cans or metal lids and screw bands for glass jars, creating an impermeable environment. Heat treatment. The sealed containers undergo heat treatment, a pivotal step for preservation. Two methods are employed. Boiling water bath. Suitable for high-acid foods like fruits, this method involves placing filled cans or jars in boiling water, destroying microorganisms, and creating a vacuum seal. Pressure canning. Used for low-acid foods prone to heat-resistant bacteria, this method employs higher temperatures achieved through pressure canners to eradicate harmful bacteria and spores. Cooling and inspection. After heat treatment, containers cool naturally, and post-cooling, they undergo inspection for proper seals, with any defective containers removed. Storage and distribution. Properly sealed and processed canned food products are labeled, packaged, and stored in cool, dry places, ready for distribution and sale. Benefits of canning process. Preservation of shelf life. Canning effectively extends the shelf life of food, inhibiting the growth of spoilage-causing microorganisms and enzymes. Food safety. Heat treatment in canning destroys harmful bacteria, yeasts, molds, and pathogens, ensuring the safety of canned food. Convenience and accessibility. Canned foods offer convenient and readily available meal options that require no refrigeration until opened, making them suitable for emergencies. camping, or situations where fresh food is inaccessible. Nutrient retention. While there may be some nutrient losses, the canning process helps retain the nutritional value of many foods, including essential vitamins and minerals. Versatility and usage. Canned foods are versatile, serving as standalone products or ingredients in various recipes, providing culinary flexibility. Considerations during canning. Proper processing and seal. Adhering to recommended canning procedures is crucial to ensure microorganism destruction and a secure, airtight seal for long-term storage. Quality considerations. Some texture changes may occur, but overall quality can be maintained, offering a range of culinary possibilities. Nutrient losses. Heat-sensitive nutrients may experience losses, but many others are generally well preserved. Storage and shelf life. Regularly checking for signs of spoilage and adhering to storage guidelines are essential for maintaining safety and quality. Sodium and additives. Reading labels is vital, especially regarding added sodium or preservatives, aligning choices with dietary needs and preferences. Benefits of packaging process in food processing. Packaging is a critical element in the food industry, serving multiple functions that collectively contribute to the protection, preservation, and marketability of food products. Its primary role is safeguarding against contamination, acting as a robust barrier to physical, chemical, and biological threats like bacteria, moisture, and air. This protective function extends to maintaining the freshness of food, preventing spoilage, and thereby prolonging shelf life. Additionally, packaging facilitates convenience and portability for consumers, ensuring easy handling, storage, and transportation of food items, both for at-home consumption and on-the-go scenarios. Beyond its practical attributes, packaging serves as a key tool for branding and communication. It conveys essential information such as nutritional details, ingredients, allergen warnings, and cooking instructions, empowering consumers to make informed choices. Moreover, packaging contributes to product differentiation and marketing through visually appealing designs, logos, and distinctive presentations that capture consumer attention and influence purchasing decisions. Extraction and refining processes in food processing. Extraction and refining processes are pivotal stages in food processing, vital for separating and purifying valuable components from raw materials. These processes are widely applied to obtain oils, fats, flavors, colors, and other bioactive compounds from diverse plant and animal sources. Below, we delve into the intricacies of extraction and refining processes, exemplify their applications, outline associated benefits, and highlight key considerations. Extraction process in food processing. Extraction involves isolating specific components or bioactive compounds from raw materials like fruits, vegetables, seeds, and herbs, utilizing either solvents or physical methods. Solvent extraction. A food-grade solvent, such as hexane or ethanol, dissolves desired compounds, which are then extracted by removing the solvent. Physical extraction. Techniques like pressing, grinding, or distillation can also extract compounds, with cold pressing avoiding heat or solvents. Refining process in food processing. Refining is crucial for enhancing the quality of extracted substances and typically includes steps like degumming, neutralization, bleaching, deodorization, and fractionation. Degumming removes impurities like phospholipids and gums using water or acid. Neutralization utilizes an alkali to neutralize free fatty acids, improving stability and flavor. Bleaching treats oil with agents like activated carbon or clay to eliminate color pigments and impurities. Deodorization removes volatile compounds causing off flavors and odors. Fractionation separates components based on melting points, often yielding specific fractions like stearin or olein. Examples of extraction and refining processes. Applications include vegetable oil production from soybeans, sunflower seeds, palm fruits, and rapeseeds, as well as the extraction of natural flavors, extracts, colorants, and pigments from various plant sources. Benefits of extraction and refining process in food processing. Separation of desired components enables the extraction of oils, flavors, colors, and bioactive compounds, enhancing taste, aroma, and nutritional value. Concentration of flavor and aroma. Concentrates flavors and aromas, particularly relevant in beverages, spices, and condiments. Nutritional enhancement. Yields concentrated forms of nutrients and bioactive compounds, contributing to health benefits. Improvement of textures and mouthfeel. Modifies texture and mouthfeel, refining fats and oils for improved smoothness and spreadability. Removal of undesirable components. Eliminates impurities, off flavors, and compounds causing bitterness or astringency. Considerations during extraction and refining process. Quality preservation. Controlled temperature, light exposure, and oxygen to prevent oxidation or degradation. Solvent selection. Choose safe, food-grade solvents with minimal toxicity and residue. Environmental impact. Evaluate and minimize the environmental footprint, considering solvent use, energy consumption, and waste management. Regulatory compliance. Adhere to food safety regulations, labeling, and product claims, ensuring the safety of extracted components. Sustainability. Explore sustainable extraction methods and utilize raw materials from sustainable sources. Consistency and standardization. Implement standard operating procedures, quality control measures, and product testing for consistent, reproducible processes.